everyone, how's everybody doing? Welcome to my YouTube channel. I'm Ayaan, and today we're going to be exploring trigonometry. So, you might be asking, what is trigonometry? Trigonometry is the branch of mathematics dealing with the relations of the sides and angles of right triangles, and with the relevant functions of any angles in the right triangle. So there are three main functions or operations in trigonometry, and a way you can remember them is SOHCAHTOA. It's a mnemonic and it helps you remember them. So the first function is sine. It's spelled S-I-N-E, and its shortened form is S-I-N. And it's equal to opposite over hypotenuse. So just a quick review if you don't know or if you forgot. So over here we're looking at it relative to angle A. So this is going to be the adjacent, since it's the angle A is right on that side, and it can't be the hypotenuse, because if it's the hypotenuse, not the adjacent side. So the adjacent side is this one, because angle A is over here, and this is the adjacent side. And the opposite side is one that is like opposite. So it's this side, because the opposite of angle A, it goes over here, so it's this side that's the opposite. The hypotenuse is the longest side of a right triangle, so it's this one. This is angle A, angle B, and angle C. Angle B is a right angle. So sine is equal to opposite over hypotenuse, and if we're looking at it relative to angle A, it's BC, because the sides are the same name as the angles. It's line BC divided by line AC. So next, this is the cosine. Cosine is spelled C-O-S-I-N-E, and the shortened form is spelled C-O-S. It's the adjacent over the hypotenuse. So the adjacent is this side, and if we want the cosine of angle A, we need the adjacent divided by the hypotenuse. So the adjacent side is side AB divided by side AC. So that's the cosine of angle A. And the tangent is opposite over adjacent. So this is the opposite, side BC, and the adjacent is side AB. So if we want the tangent of angle A, we need BC over AB. So here's an example. This is another right triangle. That's angle ABC, side AB, side BC, and side AC. And the side AB is 3 units long. Side BC is 4 units long, and the hypotenuse is 5 units long. So before I continue with the example, I'm going to explain the mnemonic. So is the first part of the mnemonic. It's sine is equal to opposite over hypotenuse, SOH, so it's so, and then ka is cosine is equal to adjacent over hypotenuse, so that's CAH, ka, and TOA is tangent is equal to opposite over adjacent, so it's TOA. So that makes SOHCAHTOA. It's up to you how you want to remember it, but I just remembered SOHCAHTOA. So here is the example again, and since because of the SOHCAHTOA, sine is equal to opposite over hypotenuse. So since we're looking at it relative to angle A, we need the opposite of angle A divided by the hypotenuse. So the opposite of angle A is BC, line BC, and line BC has a length of 4, and the hypotenuse has a length of 5. So 4 over 5 is 4/5, and that is the sine of angle A. The cosine of angle A is, because of SOHCAHTOA, the ka in SOHCAHTOA is for cosine. So cosine is equal to adjacent over hypotenuse. So the adjacent side of angle A is 3. It has a length of 3. It's side AB, so it has a length of 3. And the hypotenuse has a length of 5. So the cosine of angle A is 3 over 5, or 3/5. The tangent of angle A is opposite over adjacent, and the opposite, which is line BC, has a length of 4, and the adjacent, which is line AB, has a length of 3. So 4 over 3 is 4/3, and that is the tangent of angle A. Other than that, there are things called inverse operation. And inverse operation does the opposite of what the normal operations do. For example, the inverse operation of sine finds out what the angle is, but only if you have the opposite side relative to the angle and the hypotenuse. If you're doing the inverse operation of the sine, cosine, and tangent of an angle, you will need the sides that the operations normally use. It also adds an A in the front of the shortened word, like A sine, A cos, and A tan. So here are the spellings: ASIN, ACOS, and ATAN. So now for the example, we're using the same triangle as before, with line AB with a side of 3, and line BC with the side of 4, and the hypotenuse with a side of 5. We're still doing it relative to angle A. So now we need the inverse operation of sine A. So I have a calculator, and we need the inverse sine of A. So for the inverse to happen, we need the two sides that the normal operation uses. So since the sine uses opposite over hypotenuse, we only need the 4 and the 5. So we get the sine of A, which is 4 over 5, 4/5, and we input that into the calculator. And then after that, we get the answer, and then we get the inverse sine, which on the while being written, it looks like a sine with the power of a -1. It's easily confused by people who think it's like that, but actually, it's not to the power of -1. It just states that it's the inverse operation of sine, or cosine, or tangent. So now we need the inverse sine of 0.8, which is 4/5, and that gets us to approximately 53.13 degrees for angle A. So now for the inverse cosine of angle A. So cosine, according to SOHCAHTOA, needs adjacent over hypotenuse because ka is CAH, A is adjacent, and H is hypotenuse. So adjacent over hypotenuse is 3/5. After that, since we have 3/5 inside the calculator, which is 0.6. Although you don't see the calculator, I actually have it on screen. So it is 0.6, and after that, we need the inverse cosine of A, which gets us to 53.13, meaning that we have done it correctly. And after that, we need the inverse tangent of A. So A is, we need the tangent, and the tangent is opposite over adjacent. So it's 4/3, 4 divided by 3, because fractions is just the numerator divided by the denominator, written in exact form. So now we need 4 divided by 3. And then after that, once we get the rounded answer, we need to get the inverse tangent. Like I said before, the inverse tangent looks like the normal tangent to the negative first power, but it's only looks like that, but it only states that it's the inverse of the tangent. So we need the inverse tangent of 4/3, which gets us to approximately 53.13, which is the same as what we got for the inverse sine and inverse cosine, which means that it's correct. So now that we've finished the example, let's review what we talked about today. First, we talked about the 3 functions in SOHCAHTOA. SOHCAHTOA means sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Relative to angle A, this is the adjacent since it's right next to it, the opposite because it's the opposite of angle A, and the hypotenuse, which is the longest side of the right triangle. Trigonometry, again, is the branch of mathematics dealing with the relations of the sides and angles of right triangles and with the relevant functions of any angles in the right triangle. Inverse operations do the opposite of the normal operations. For example, if we're getting the inverse operation of sine, we need, since sine is opposite over hypotenuse, we get the inverse operation of the opposite over the hypotenuse. And it's the same for inverse of cosine and inverse of tangent, except that it's swapped with the respective values of their actual operations. Thank you for watching. Please be sure to subscribe and check out my blog at blogofayaan.wordpress.com. Thank you for watching. Bye.